Cassini's dive into Saturn capped off 20 years of scientific discoveries and breakthroughs. And even though the Deep Space Probe is no more, its sacrifice is yielding results. During the orbital maneuvers that brought the probe closer and closer to the gas giant, Cassini passed inside the rings and skimmed the planet's upper atmosphere several times. On the first 11 orbits, the probe took measurements using the radio and plasma wave science instrument. And when scientists looked at the data, they found that Saturn has a cold, dense ionosphere. Cassini's data provides the first up-close measurement of the gas giant's charged upper atmosphere. Ionospheres are created when ultraviolet radiation from the sun hits the atoms of a planet's upper atmosphere, splitting some of the atmospheric particles into charged ions and forming a plasma. If you've ever picked up a radio broadcast from thousands of miles away, you've interacted with Earth's ionosphere, which reflects radio signals around the planet. However, Saturn's ionosphere is a little different than Earth's. The planet's enormous rings affect the way that the ionosphere is charged. When Cassini passed into the shadow of the rings cast on the planet, the amount of ionized plasma dropped immensely. Saturn's D-ring also appears to be affecting the ionosphere. Researchers theorize that an interaction known as ring rain may explain some of the ionosphere's quirks. While the shifting plasma in the ionosphere is a major finding, it only came from the first 11 orbits of data, so there's still much we can learn from Cassini's last hurrah.